Here we are back for the second video of this lesson. We're now going to sketch one involving x squareds, which could be quite interesting. Let's see what happens with this. We're going to go through the same process. Y-intercept, substitute 0, and it works out as 1. X-intercept, equate it to 0. And we get plus or minus 2, 1 to the nearest at 1 decimal place. I begin to wonder if we're going to get a parabola or something. dy by dx, let's have a look and see. Once again, I have to use quotient rule, derivative times the bottom. So there we are, derivative 4x times the bottom as it is, minus, and then it's the derivative of the bottom times the top. There we are, quotient rule. All over the bottom squared. And we're going to put it equal to, well, we're simplifying first, and then we're going to put it equal to 0. And if you solve that, you get x equal to 0. So therefore I know now the x value of a turning point is 0. Second derivative. So now we're having to differentiate that. We have to differentiate again. We could have just differentiated. No, we are, I think, yes. We're differentiating this here. Right, top derivative, 18 times the bottom as it is, minus the top as it is times derivative of the bottom. And that's a chain rule. 2 times x squared minus 9 to the 1, there it is there, multiplied by the derivative of the inside, 2x. And if we substitute 0 in there, we could substitute right at that stage to see. You'll find you get, because 0 is so easy for substitution, you get less than 0, so it is a local maximum. It's got to be at 0, 1, but we can see if we substitute 0 into here, we're going to get 1 anyway. Let's look at asymptotes, because they've got to be asymptotes, the fact that there's division by x's. So, this one I know it's plus or minus 3, because that factorizes to x minus 3, x plus 3. So therefore I know x plus or minus 3 are the x values you won't be able to have, so those are the ones that are going to give you a limit of infinity. Therefore, x equals plus or minus 3. Let's have a look at the horizontal asymptote, where it's now the limit, y equals the limit, as x tends to infinity. Once again, I indicate it's infinity over infinity, so it is indeterminate. So L'Hopital's rule is appropriate here. So we can differentiate top and bottom. And that's still infinity over infinity. So we can, oh no, we don't need to, because this will simplify now. 4x over 2x cancels down to 2. So therefore limit of 2 as x tends to infinity is 2, the constant. So therefore y equals 2. And there it is there. So now we need to work out. You are going to have to do a little bit of work. Clearly, this has got to come down here, and it's going to be asymptotic here. I think what you should do is substitute 5 into the original to see whether it's here, down here, or up top there. And if you substitute, or to any number really, if you substitute any number greater than 3 into here, you'll find you're going to get a number above that asymptote. And if you substitute any number less than -3, you're also going to get a number above that asymptote. We're substituting into the original. So therefore, we know that we've got sort of 2 hyperbolas here, and then the one below. So there we are. There is our graph. That's the end of this little video. So now you can go back to the exercises, curve sketching 2 exercises, and do number 3. The answers are on there as well, so you can check the answers, but remember once again, if you have to look at the answer while you're doing it, that's fine, but then remember, please come back tomorrow or the next day, whenever, just to try it again, see if you can do it on your own.